We are still working on the central limit theorem. So now we're going to talk about central limit theorem for means. So we're dealing with quantitative data here. Somehow we know the population mean, mu, and the population standard deviation, sigma. Remember, Greek letters for population parameters. Now, we go out and we do an infinite number of samples, all of size n. We don't physically do that, but theoretically, we had all possible samples of size n. Each one of those samples would have a sample average. X bar means sample mean. Your book uses Y bar. I use X bar because that's what your calculator uses. They mean the same thing. Now, we're supposed to check all these conditions. The population should be nearly normal. This one, we don't really have to stick to this condition. It's a numbers game. The closer to normal the population is, the smaller of a sample size we can get by with and still use the central limit theorem. If your population is perfectly normal, then I can use any sample size I want. We already did that. That's what we did in chapter 5. We made predictions about individuals. If the population's not normal, then we need our samples to be a little bigger. And the less normal the population is, the bigger our samples need to be. So if the population is close to normal, we can get by with small sample size, small being maybe 10. The general guideline is no matter what your population is, if your samples are bigger than 50, you're probably okay. Samples must be random, non-biased samples. They must be independent. The act of taking the sample can't influence other samples. Just like with proportions, the samples can't be too big. You don't want them to be bigger than 10% of your population size. And we just talked about this large enough condition. Then if you meet all those conditions, then your sample means will follow a normal distribution. So no matter what the population looks like, the individuals might not be normally distributed, but the samples will. And this is function notation. Nothing is being multiplied right here. That says the mean of all possible sample means equals the population mean. So you got some population, maybe it's a bimodal population. Doesn't matter what the original population looks like. You go out, you do a whole bunch of samples. Everybody, I send you all out and I say collect 100 data points for me and take the average. And you come back to me with one single number. You don't tell me all 100 numbers, you tell me your average. So I collect everybody's average and I put them all in a histogram. Those averages will be a normal curve. And the average of all your sample averages will be the same as the population average, and the standard deviation will be sigma divided by square root of n. Okay, this is literally the most complicated thing we do all semester. It's kind of meta here. You have to be thinking that we're talking about samples, not individuals.